All right.
Keywords?
Yep. This is the zero W. So this one has wireless embedded. It's small. But that's the same thing as this. But for a size this small. You put this on your pocket. I've seen some people hack this to add the USB, and then you can actually just plug this into your computer, and then basically you use the Raspberry Pi, but you're using your laptop screen and keyboard and mouse, so you don't need.
Was it that external?
Yeah. Yes.
How much memory does that?
Not much. I think it's like 2 gigs.
Oh,
It's less.
It's too much.
Well, yeah, sure. But it's less than this. I think this one has 4. Yeah. Or maybe it's 1 gig. I think it's half of that. Yeah. It's not very powerful. I mean, it takes maybe 5 minutes just to go into the operating system. But once it's there, it's quite fast, but it takes a while. It's okay for server stuff, like Node.js runs in here, Python or whatever. And, this is so tiny. Yeah. I got that for free. I subscribed to this Pi Hut. It's like a magazine, and they give out like Raspberry Pi stuff, and it's 20 euros a year or something like that, and you get things like this from time to time. Before I subscribed, the last time I subscribed, I wanted to get the speaker. They actually had the speaker set up for free. I was like, holy shit, I wanted to get that, but I didn't reach on time. They had already sold out, and but I got this one now, like maybe a couple of weeks ago.
In UK, they have one new Raspberry Pi shop.
Yes, I saw a physical. Yeah. I saw. Yeah.
Oh, and then the new system is the Raspberry Pi now.
Okay, cool. Okay. Yeah, we should see it. For some reason, my camera's not working. It's okay. Oh, it's recording the screen itself. I wanted to show like a small window here, so they could see us, but I don't know why. The camera is not working. Maybe some firmware update or something. I don't know. Have they started programming it?
They have, but not for the assignments.
Yeah. Only in the lab.
Only in the lab, yes.
And how's that coming?
I think normally because it's this course assignments are not actually graded.
Yeah.
It's like it's hard to get people to work.
Okay. Yeah.
People are some of them are coding, others are just
Doing something else.
doing something else, or when you ask them, they say, "Oh, I don't bring my machine, I go down to it." Last year, because it was graded, everybody was trying to do something.
Are they familiar with the shortcuts for creation of text of the code and stuff? If they start coding, they just try to memorize what to write. That's not going to end well. Yeah. That was actually like for me to learn Kotlin. It was so easy because Android Studio does everything. I'm preparing the class for next week. And then how to do things. I'm thinking maybe I should also do some live coding for them to see.
I think it's
Today is actually the class is going to be short. There's not much. I know someone who's going to that.
Ei se sinänsä kovaa hommaa ole, mutta minä onneksi näin heti ensimmäisenä siinä, että se oli vain, että minulla on vaikka lähes puhuta heille, mitä toki minä en ymmärtänyt sitä hommaa. Mä testasin siitä.
I don't see anyone inside, so I guess we should start. Okay. Today we're going to talk about context-aware mobile services. So we are week 5, 2 more classes, and that's it, basically. Then we go to spring break. There's a break. I think you have like a week off from schools here. And then after that, you have your project work, which is last period of the class. These are guidelines based on the credits of the course. So you should try to work on your project about 2 hours a day. But actually, this is based on last year. So last year, we actually didn't have any of the project work during the first period. So I guess this year it will be probably a little bit lighter for you because you have already started working on the project anyway. So I think it's okay. Just keep in mind, it's not just programming. You have the video and you have a presentation, and there's this peer evaluation. So you will actually grade everyone else's. You will see everyone else's work, like their videos, before actually the presentation. Yeah. I still need to book the lecture room for this last event, but usually it's not formal. You know, you just have every team come present their work. We talk about it. They talk about like what was difficult and things like that, and that's it, pretty much. And everyone eats chocolate, and that's a wrap. But yeah, okay. So today we're talking about context-aware systems, mobile services. Anyone is familiar with the word context? What it means? Any hints? Any, gut feelings? What is context? In a common sense.
Surrounding environment.
Surrounding environment. That's one way to see it, yes. Anything else? I would say you're close. So it depends a lot on who you ask. So if you ask, for example, an anthropologist, it's basically the circumstances that are around an event or statement or idea and in which it comes fully understood. But if you ask an author, it's actually words. Parts of a written or spoken statement that come before or after, like a passage. But then if you ask an engineer, it's more about data. So it's about what do you know about a task that can be saved to allow a task to be interrupted. So we're thinking about like computer science in here. So when we think about a context-aware system or computing, basically it's when a system uses context to provide the most meaningful operation or information to the user, depending on the task at hand. And then usually we categorize those contexts into 3 things. One of them is presenting information to the user. The other one is actually doing something automatically for the user, or actually recording or tagging context for you to later check. So more like historical records. So if we think about context, it's actually been a challenge that has been around for many years. Any gut feelings of how long have we been thinking about context like computer scientists? The answer is going to surprise you a bit, because most of us didn't even think about computers back then. So 1969, actually. I have a video here showing you actually before the internet was created, before computers existed actually in people's homes. And so you'll see on this video how context is actually different. No. Ah, damn it. Okay, just a sec. I did test this yesterday. How could this be? All right. That's really weird. Okay, I got it here. Yep. Okay, let me.
Will be channeled into the store of her choice.
Okay, let me put this back.
Fingertip shopping will be one of the many homemakers' conveniences. This video console will be channeled into the store of her choice. There, a camera will scan a display of wares, which she will select by push button. Another part of this console is a household monitor screen, which maintains a watch on critical areas in the house, swimming pool, or yard. What the wife selects on her console will be paid for by the husband at his counterpart console. All bills and transactions will be carried out electronically. A central bank computer will debit the family's account the amount of purchases and credit the department store, for example, informing the family's home computer at the same time. Father, at the touch of a button, receives an instantaneous printed copy of his budget, the amount of taxes he owes, the payments left on the car, and so forth. All documents and household records are available on the video screen for immediate reference. Also at his disposal is an electronic correspondence machine, or a home post office, which allows for instant written communication between individuals anywhere in the world. To maintain these and hundreds of complex electronic circuits, a monitor checks all circuits every few seconds, inserts a backup circuit if and when trouble develops, and alerts the communal service agency for replacement.
Anyway, so if we take a look, think about this.
My husband and I both took the DNA test, and
okay, so if we think about this video, what did you notice? What was kind of weird about this video? Besides the fact that it's really old. Any ideas? Comments? Come on, not too early yet. So I will start. Notice that there's no mouse. Yes, interaction is done with buttons, almost like a radio. And that was because at that time, you know, things like keyboard was actually just a typewriter, and that's it. And they do have some typewriter here. But the interaction with the computer itself was actually done with knobs and pushing some buttons, and you would make something happen. So this video is actually called a concept video. None of this actually was operational back then. Because, I don't know if you noticed, but what the person was seeing on the screen was actually a piece of paper moving to the side, and it was just changing. So this just wanted to basically conceptualize what it would be like to live in a home where you would have a computer dealing with stuff like shopping and checking your bank and do these things. There was no email. It had not been created. They talked about having your own post office at home, and that later became the fax. So you see, this is kind of like when you have a piece of paper and sketches, your limit is your imagination, basically. And that's one of the reasons why I asked you guys to think about how your app is going to be or your service is going to be first on paper. Because it's easier to think like that with no boundaries. You're not restricted by technology right now. Although we can do a lot of this stuff already nowadays. All right, so let's go back to the videos. I'm quite disappointed that that video disappeared. I will have to replace it, but I will. So I guess the major takeaway I wanted to remember is that context is hard. Like, it's really hard to get it right. And that's because it's part of every science, like computer science discipline that you can think of. Like, if you think about machine vision, it's basically trying to make sense of the context of what the computer is actually looking at, which is pixels. You see? How they go together, how they fit together, that creates the context of the image you're looking at. Artificial intelligence, for example, understanding what people say and do something for it. Learn over time, and other things. So I have this example here. This one will work, otherwise we wouldn't see this guy here. So sometimes I see these movies and I start thinking like, oh, no, that's not gonna work. But anyway, this is, in my opinion, context done wrong. And I want you to, after you see the video, now that I've talked a bit about context, why is it wrong?
1974, Spark X1 model scan complete, sir.
How many buildings are there?
Am I to include the Belgian waffle stand?
That's rhetorical, just showing. What does that look like to you, Jarvis? Not unlike that. In which case, the difference will be here. Highlight the industry. Where's the footprints? You're ready.
What is it you're trying to achieve, sir?
I'm discovering, I'm rediscovering irrelevant. Loose landscape and shrubbery, the trees, parking lots, exits, entrances. Structural protons and neutrons, using the pavilions. After almost 20 years, still taking me to school.
All right. So what's wrong with this? Is there anything wrong? I said before, like, context is really hard. And then somehow in here, this computer was able to understand vocally very ambiguous things. Things like, oh, just get rid of this and that, and that's it. And then the other thing was the gestures. understanding gestures, where the interaction between him and the device is actually very, like all these things, which basically don't mean anything. You know, things happen in the screen. And then it's very also difficult. Like if this was actually possible, it would be very difficult for him to know what's going on behind him. Because if you remember here, like he had stuff happening all over him. And so that means that if you can't see with your eyes, you don't know that it's there. And so let's say that there's an error message or something behind him, he would miss it. So that would be another thing that where this kind of system would actually fail. Of course, we could also do it so that if there's a message there that he needs to pay attention, make it visible to him. Of course, there's a lot of mitigations we could do. I'm not saying that this will ever be impossible. There's some work done on these smart contact lenses where you can actually overlay information in your eye. Lasers. I don't know if you've seen, Intel has these new smart glasses that have been prototyping where it actually shoots lasers into your eyes and you can actually see stuff in front of you, which is really scary. But yeah, I mean, maybe in the future, things like this will be more prominent. And I do have a video of such smart lenses to show you. But I guess the point I'm trying to make here is that it's okay to idealize and think about these things, because only like that can you address the challenges, okay? So in research, there's been a lot of context awareness done work in the past, mostly because of smartphones. So as smartphones started, and phones actually started to be available, and the sensors they have, it actually allowed researchers to start playing around with the fact that you can actually sense and present information to the user anywhere he goes. So here's a project that looked at using sensors in a phone to create a context-aware system. It was actually a recommendation system.
Select any activity and you get a set of recommendations based on the current time and place.
So we take this for granted nowadays with Google Maps or Yelp. So where you go somewhere, it will give you recommendations based on where you are at a specific spot.
Selecting to the right, it will show you the ratings. You can set yourself.
So you can see a rating, how some place is good or bad. You can see people's comments. You can save places.
And you can see professional reviews by selecting that. You say, well, really, you know, I'm not close to lunch, but really I'm down here to buy books. So let me go in here, change my activity to buying.
So this was something that they also thought about, was that the interface would change depending on what is your intent. What do you want to do? I want to go eat. Okay, I see restaurants. I want to go book shopping. You get libraries and stuff like that. So it had this kind of thing.
Change the distance to be.
And you could set filters also, like depending on how much are you willing to walk to get there. Things like this. Okay, so this is a demo of that. If you see this, I mean, this was 2010, not so long ago. And that's how phones looked like back then. Then 2011 came and the iPhone was introduced, and then Android devices started to appear and everything changed, literally. You stop having phones like with these kind of keyboards. Have you ever seen the first Android phone? It's called the G1. It actually had a keyboard on it. And then when Apple introduced the iPhone with no keyboard at all, Google was just like, oh, shit. Let's go back to the drawing board. Yeah, so yeah, I actually programmed for the G1 back then. It was quite the device. Anyway, so I think if you think about context-aware services, it's all about the user. It's all about how computers serve you, always. So this is Majidi. I have here another one called Gimbal.
From the smallest storefront to the largest stadiums, mobile is transforming the consumer experience, led by the company that transformed mobile. With the Gimbal platform from Qualcomm Retail Solutions, you can bridge the physical and the digital, connecting customers to stores, events, brands, everything around them, wherever they go. Gimbal geofencing lets you reach out and engage them the moment they arrive, so a fan can be treated like the team's most valuable player. So customers can get timely, personalized service that makes them even more loyal. And commuters can be proactively updated from point A to point B. You can also place secure, power-efficient gimbal proximity beacons inside and out to enable micro-location awareness. They're available in sizes that make it easy to put them anywhere you want. Gimbal empowers people with a digital 6 minutes, connecting them to the places, things, and brands around them. It's an entirely new way to deliver personalized service and strengthen customer loyalty. You can engage people when and where it matters most, providing information that's both timely and relevant. And location is only the start. Gimbal profiles let you bring a personal touch to information and services. So you can offer people the things they're most likely to want, at the moment they're most likely to want them. And because it's based on context, the conversation always stays relevant, even when people don't stay in one.
So the video here says something that is actually quite interesting. So when people want, when they want it. And so that's one of the things that, companies like Qualcomm and others, they've been really struggling to get it right. Because that requires you to also understand your user, to get to know your user. And in a way that justifies a lot of the data collection that you see from big companies in terms of profiling the user. And the reason for that is because they need to tailor, or they want to tailor their services to fit your needs. Google is very keen on that. If you think about Google Assistant, they kind of market it as the Google for you. So basically, it learns from the way you talk, it learns from the things you search for, and then what is your interests. So that device that I showed you, and it's passing around somewhere, where? That way, okay. It's called the Ruby tag, and basically that device allows you to code what happens when someone is close to it. It's actually a beacon also, but it also is a sensor. So it also measures things like the ambient temperature, humidity, motion. So and it's also waterproof. You can actually put one of those inside a aquarium, and it will measure the temperature. I've been using it at home to notify me when my sauna is ready. I just have that inside the sauna. It uses Bluetooth based protocol. Actually, it's not actual Bluetooth itself. It's compatible with Bluetooth on your phone, but the range of that device is actually quite big. Because anywhere I am at home, I can actually get the reading from that. And so these things are crazily cheap. You get a set of 3 of those for 60 euros, and the battery of that thing lasts for 5 years. So, you put one of those, for example, here, and we could know, for example, every time you come into this room, if you have Bluetooth on your phone, for example. But you could also do the opposite. You could provide services. You can actually code what information is actually shared with the user with that. So you can share, for example, whether or not there's someone in here. So for example, the humidity goes up the more people are in here. Because we breathe and it raises the humidity in the room. So context is also about understanding what the sensors tell you. And then making judgments based on that. Okay. And I think this one here is almost done.
The Gimbal platform also features consumer-friendly opt-in, opt-out, and privacy controls that earn trustee certification. The Gimbal all-in-one solution, delivering more relevant information, more rewarding experiences, power of context awareness. Visit gimbal.com to learn more. Help shape the future of mobile.
Yeah. So another device that is becoming quite popular is the Raspberry Pi. I actually have two of them. This is the Zero, which is really tiny, but it's almost as powerful as this. And it has wireless, it has Bluetooth in it. This one even has a USB microphone, which is tiny. It has a camera. I put a camera in there. But this is a computer. And you can also add sensors to it. And it's relatively cheap. So when you're thinking about your project, you could think about how you could use these external devices to provide you with information that it's really difficult to get just thinking about from your phone's perspective. So for example, this one here, I actually spent the weekend programming it. It has Google Assistant in it. You can search for, you can ask the weather, you can ask, and it will talk back. And right now I'm programming this to recognize people's faces, because I wanted to say hi every time someone goes into the hallway in our floor. So that's my side project. But I've been thinking about, how can I provide some information to whoever visits our lab? And we could ask things like, where is this room? And it would show you the map where it is, for example. We could ask, like, is Denzel around? And it will tell you, like, whether or not I'm at the university or not. It might not tell you where I am exactly, because I don't want you to know, but at least you will know if I'm around. I mean, those are just a snapshot of the things I'm thinking about this. And it just runs here. The Raspberry Pi is 35 euros. This camera is 5 euros. And this USB thing is 2 euros. Of course, it costs money. But compared to a computer, it's way less. You can get these. You can also open it if you want to see how it is inside. Not this one.
Which kind of connection?
Bluetooth and Wi-Fi and Ethernet, actually. Any connection you want. We actually have a bunch of Raspberry Pis. So if you want to try one for your project, just ask us, we will give you. Okay? Yeah. All right, so that was Gimbal. So if you think about it, context, I did say context is really hard, and it's about understanding the user and how do you use computers to provide you with something useful. So Intel actually had a very nice experiment where they actually asked people, what do you want in terms of context? What do you want for a computer to be able to do? And it's really funny how it works out. I'm not going to spoil it, so I'll just play it.
Yeah, no, it's on my phone, probably the financial information, a lot of times maybe location. Yeah, where my location, where I'm at.
I don't think I would tell it my social security number.
It might, have an act, it could sense how I was feeling throughout the day, depending on how I use or what I was checking up on. That would be a really neat thing.
I've always said I wish that this put my remote control to my TV, my clicker doesn't lock my car, my starter to my car.
I would use my phone to love my favorite locations, my favorite restaurants, my favorite friends.
Restaurants, I love to eat. I would use my phone to go get like what I like, what foods I really like, how to search for those foods in particular.
I think I would love for it to automatically plan a nutritious, healthy meal for me without me having to go to an app or a website.
Something into my mood, maybe the record music that it did a better mood, recommend games, applications. They tell me it's great.
So it seems to me that we are pretty much doing already what people want, right? Tells you where you are, tells you what restaurants are around you, you can keep track of a list of restaurants that are favorite to you, you can keep track of favorite contacts, who is important for you. What else did they mention? Healthy diets, I guess that's a bit more tricky because it depends on the person, right? But you can keep track of what you eat, and that way you can choose to eat more healthy. But in general, it seems to me that, you know, context seems to be a solved problem. And in many ways, it is better nowadays than it used to be, simply because you have more sensors in your phone, right? And the fact that you can actually build any app on your phone and you can code it to do different things for the user, it becomes a bit easier. Have you ever heard this expression, there's an app for that? So there's this expression that says that no matter what your need is, there's an app for that. And so it's kind of like we're going a bit towards that. So this platform, for example, Movia, was founded in 2003. So if you see the year, 2003, this is really old compared to what you saw before, and the fact that there's no smartphones in here involved at all, or phones in general. So this company was already thinking about the potential of the phones to be able to provide you with context information. So I will show you, oops.
Movia explains how data fusion enables apps to anticipate users' needs. That's Lee on his way to meet his girlfriend, Suzanne. He uses an app to find out when his train is coming. Nowadays, there's an app for everything, but this can be quite long-winded. Lee needs to search for the right app, start it, and comb through for info. And in theory, he'd need to keep checking for updates. What if the apps could give answers before Lee has to ask? Sounds futuristic? Well, Movia provides everything needed to work that magic. Movia is a pioneer in making sensor data available for app developers. Now Lee thinks he's running late to catch the train. But thanks to Movia Technologies, his smart app recognizes him running in the direction of the train station. It informs him that the train is late anyway, so there's no need to hurry. The moment his girlfriend Suzanne arrives, her phone sends an SMS to Lee. At the parking lot, it even remembers where she parked a week ago. It tells her about traffic jams on the way without the slightest hand movement while driving. How does it work? Movia provides a data fusion engine. This engine processes data from all possible sources with high performance, and it can run all the time because it has an ultra-low power usage. The development toolbox enables app creators to use all this fused data. With the cloud-based model library, Movia offers ready-to-use models for developers, like movement patterns and much more for all areas of life. And it works on any operating system, with any architecture, and any sensor. All of this empowers future apps to anticipate problems on Suzanne's and Lee's way and helps bring them happily back together. Movia, smart apps for smart people.
So this company actually has an interesting origin story. So these were actually researchers who got together to think about like how sensors could be used to provide services and recognize context. And they actually got bought by Qualcomm later. And it's actually on your phone right now. Every single Android and iPhone has EventSense sensors. And these are basically all the filtering that happens on your phone in terms of noise in your sensors is processed by EventSense. So in your phone, together with Android or iOS, actually, you have this engine that literally processes the signals that come from your sensors, removes the noise, like so that you don't get bogus data, and also provides the API to retrieve this data. So in the backend, when you do on Android, like you use the sensor manager to retrieve the accelerometer data, you're actually talking with this on the backend. And so if you log like what kind of sensor is this or what is the model of the sensor on your phone, I can guarantee you 90% of the times it's going to be an EventSense sensor. And they're quite everywhere because now they are expanding to all sorts of IoT. So as you can see, this company actually is pretty much on all the consumer electronics you can think of. And that's just because they have gathered the most expertise in building these sensors. And also leveraging them for very particular use cases, like flight control for drones, wearables, like things like this, like the Segway, keeping the balance. And so the company is actually very pervasive that way. So rules of thumb when you build a context-aware system. So I think you should think about the user first. That would be the #1 rule. And that's why it's there on the top. So normally you would want your application, if they do something for the user, something that the user would expect it to do, and not something, you know, I can't open the door right now when you ask it to open the door, for example. Yeah. And then, for example, you know, we get a lot of information every day. So the other thing is that if you do context awareness, you need to realize that you're not just the only app around the user. And so we need to think about what is important. You won't be telling the user that, oh, I failed to get a sensor data. You'll just retry again, and then whenever it's possible. So that happens, for example, on GPS. So on GPS, if you think about Google Maps, when the sensor is not so accurate, it doesn't tell you that, or it fails to get a location, it doesn't tell you like, oh, something went wrong. It doesn't do that. It just shows you like, okay, I know you're somewhere here based on your history, and then you see like this big bubble of accuracy. And then as it gets to your location, it becomes better. So that's another way to only inform the user when it makes sense. Okay. The other thing about context is that because we are using a lot of sensors, is battery. So if you think about your phone, for example, if you're using all the sensors on your phone, I actually did that experiment myself, where I turned on all the sensors on my phone, and the phone literally died in like 2-3 hours. It was dead. Like fully charged, dead. And the reason for that is that sensors consume power. And when you're using sensors to build something, you need to think about, do I need this 24/7? Do I need this all the time? And then leverage that. So Google, if you're using Android, they have an API called Awareness API that literally allows you to retrieve a lot of the context in an energy efficient way, where you can say, okay, every 10 minutes, I want to get the location of the user, the place where they are. So there's a question there. What is the difference between place and location? So location is GPS coordinates. A place is actually, is it a university, is it a shopping mall, is it a grocery store? And so Google actually provides you with an API for you to retrieve what kind of place is this based on your location. And that they use basically the Google Maps API for that, where you can retrieve, okay, what's around you, is it a shopping mall, things like that. It also does classification for physical activity, so whether you're walking or running or biking or in a car, for example, in a bus. It also has beacon scanning, detecting whether or not you are using headphones, so you can actually interface with the user using the headphones, for example, or turn on the music or something like that. And also the weather conditions. And the way that they make this battery efficient is that it actually takes snapshots. And so every 5-10 minutes, it actually collects the data on all of those, all in one go, and then turns off. So you will get always what is the last reading that it managed to do, okay? And then you can even do fences. So using the fences API together with this, you can also do it so that you only want this to run if the person is in a specific location, for example. So that way you also save power. Is there anything like this for iOS?
Yes, yes. For example, range function and the beacon function.
Yes.
iOS.
Yes.
So,
but it doesn't do snapshots of multiple sensors at once.
Yes, we have. So generally on iOS, it's if you use location sensor, it's automatically combine everything. You cannot access to the GPS data directly.
Okay.
So it may but inside iOS, it's
yes.
The iOS estimates the location using Wi-Fi and GPS and everything.
But that's only location. What about like physical activity and weather and other things like that?
For
weather. physical activity? Does it do that? Do you have like a library for that?
Yeah, activity is yes, and place is yes.
Okay.
Beacon is yes.
Okay. So very similar.
Yeah, almost similar.
Okay.
But I think no weather
Yeah.
API.
Okay.
But it's hover. Yeah.
Okay.
External API. So
Okay. Yeah. So if we think about an architecture of a context-aware system, you start with the sensors. And then from the sensors, you retrieve data, raw, in this case, like unprocessed. So if you think about accelerometer, will be the X and Y and Z. You do some pre-processing, which EventSense already does quite a lot of that, like removes the noise and things like that. And then in general, you need to store that data somewhere and manage it, and then build your apps on top of that. This looks very familiar, doesn't it? Because this is actually what you have on your phone. Literally, your operating system is doing this all the time. It's using the sensors you have, retrieving the data there to adjust the brightness automatically, answer the phone call whenever you get a phone call, turn off the screen when you put it next to your ear, things like this. Okay? So during my PhD, I built a context-aware system, basically an app that does a wrapper around a lot of the sensors to present information to the user in a way he would understand it. It's free, so if you want to try it, you can try it. But basically, we've been using it for conducting research. I think I already talked about this. That's a screenshot of how the app looks like nowadays. So if you think about requirements, and let's say that your app or your project will do context awareness, these are the things that you should think about. So first of all, acquisition of data, right? Where are you going to get the data from? This might be your phone, but it might also be a server, like an API. The other thing you're going to have to think about is how do you store this data? How do you aggregate it so that your phone doesn't run out of space? You can't possibly store all the data you want, right? So that also means that you need to keep track of its integrity. So that means that if, let's say, for some reason the phone runs out of memory, what do you do then? Does your app stop working? Do you clean up after a certain time? Let's say you only keep a time window of a week of data, and the previous week you don't care anymore because it's old, and you just clean. Consistency. That one is quite interesting. So given the same input, you get the same output. So if you have the same sensor data, you expect the app to react the same way all the time, right? And then discovery. So how does the user know that your app does a certain thing? So by that, I also mean things like gestures. So if your app has gestures to navigate, how do you make the user know those gestures, for example? So query. So being able to retrieve the data when you need it. And this is the context itself, not the raw data. So for example, the context could be, I'm in the university. So being able to ask your app, like, where am I? And it will tell you at university instead of telling you the GPS coordinates. Adaptation, this one is a bit more tricky. So if you have a new source of data, usually you have new functionality. And this basically just means that what your app does today might change tomorrow, basically. And that's going to happen as you start developing your app. You probably will add new features or new things as you keep developing and you get things done. Reasoning, so understanding the data itself, making assumptions, that's also tricky. Because you will see that a lot of the times you make an assumption and then you give the app to someone else and then the person behaves in a different way or understands the data in a different way than what you thought it would be. Okay. So quality indicators, so I have here, there's this expression in machine learning, garbage in, garbage out. And so that means that depending on the data you collect, you can build better services. So if all you get is garbage, basically your app won't be able to do anything useful. So I can give you a very concrete example of that. So Microsoft wanted to make a bot to do like customer service. And they had that bot in Twitter. And then of course, it would learn with the questions that people made, okay? Things went terribly wrong when the bot started having answers that were quite racist. Another example of that is Amazon's recruiting. So they tried to automate the recruiting. Given that in the past, they were using historical data of the recruiting that Amazon has done in the past, what happened is that the recruiting system would only recruit white and male, that's it. And that's just because of the history. And so that's why, that means that the data they had already in the beginning to learn was already biased. And that means that whatever they built would always be biased, okay? And then there's the integration part, which is basically, does your service act on its own or does it integrate with others? So a good example of that is, for example, the Google Assistant. Nowadays, Google Assistant can run on multiple devices, everything's integrated. I can ask my phone to turn on the TV to play a video on YouTube. And I do that through my phone. Or the car or things like that. You can also do that. Yeah, so think about these requirements. Of course, you don't need to solve all of them on your project, okay? But it's just something to get you thinking about, okay, how I'm gonna deal with this. Is this something that we should think about? How can we plan for this? How can we support this kind of thing, okay? So there's been actually a lot of years in context awareness. I mean, I showed you the video in 1969, but historically, most of the contributions in research and academia and industry has been about building systems, like full-fledged systems. And they have been, building tools that allows you to create these things easier. I mean, Android itself is a context-aware kind of a system because you can use it. And so there's this fear where context awareness systems could either be a good or a bad thing. So I will show you visions. So I will show you first the good one, and then I will show you where things can actually go wrong if we think about this. So I'll start with the utopian one. not a Tesla. So what you're seeing, I guess, what I wanted to show you here, or the point of showing this video, is that everything's integrated. The user is able to shift the attention between one device to another. So for example, when he got a phone call, he could move the call to the table, the girls could talk with the grandma and whatnot. It's almost like, you know, computation is everywhere, literally. Of course, there's a lot of, you know, hypotheticals in here, but a lot of the work that is actually shown here is quite possible nowadays. Just that it's extremely expensive to have a home built like this. Some of these are still under development. So, did you know, for example, the company that makes these is actually the same company that makes the glass you have on your smartphone. This is the Gorilla Glass company, Corning. So they're also responsible for making the touch interface, the panels where you actually put your touch. So a lot of the stuff they have showing you basically is to demonstrate their expertise in making surfaces that are interactable. These also come in this year, like flexible displays. But yeah, so this is the utopian vision. And this assumes technology works flawless, like there's no mistakes. Things happen the way they should. And you know, there's no network problems, there's no errors, there's no bugs in the software. But we all know better, right? But anyway, this would be a day where technology would be, you know, everywhere with no problems. So I have another one that is the dystopian. Oh shit! I guess it's all out again. Just a sec. Okay.
This is what it looks like, and this is what it feels like. Perfect. Good job. Excellent. Well done. Well done.
life is a journey, and this journey, we all want to do more, experience more, feel more, and live with no boundaries. And why shouldn't we? Sight System presents Sightseeing through Being More Than
Patrick. Patrick.
Oh. Hi. Hi, Daphne. How are you? Sorry. It was great.
Thank you. A great jacket.
It's a sports jacket, so that's official.
What do you mean?
Sorry?
What's the difference between a sports jacket and a normal one?
I guess a sports jacket is for people who want to look good even when they're chased by the police. Anyway, I hope you're hungry.
Yeah.
That's the best burger we have.
Oh, actually, I'm vegetarian.
Oh.
Really good. You didn't say it on your profile. So.
Well, I don't write everything on my profile.
You want to go somewhere else?
No. I'll find something else.
Well, how about a glass of wine for starters?
Yeah. Great.
So, are there any other things in your profile that you didn't write about that I should know, or? Are you scared of driving by yourself in the city?
Not really. Besides, I'm about to hit level 5 American Master.
Pretty impressive.
What is scary though? On the last route, my site crashed. So scary. I didn't see anything. I could find my way home.
Site doesn't crash.
Well, it did. I was totally lost. I didn't see anything.
That doesn't happen since I left that.
Did we live here or something? Really?
Yeah.
Wow. What did you do there?
Nothing serious. I'm just in simple.
I read about your company in the news. Is it true that you guys implement stuff and manipulate people's lives?
I don't want to. Not with a New York City pretty lady.
You know, you really get me.
You know, I can tell what you're thinking.
Really? What?
Well, finish cooking. How about we go to my place? For a nightcap?
Well, you're so good at reading my mind. I should know what I'm going to say.
Sure is.
Back here.
It's all right, I guess. A toast for a perfect night. Why are you drinking?
What's that? I'm taking out.
No.
I cannot resist my love for you,
I said wait. Let's try this again.
Quite scary, huh? So don't buy smart glasses or smart anything. But yeah, so you saw also on the first video, the first lecture, China has this quite intensive camera surveillance system where they actually use that to monitor traffic accidents, prevent crime, and things like that. Some people might think that, you know, I don't want anyone to be monitoring me or anything, but I guess in good hands it can be used for good, but in bad hands it can actually be really bad. So yeah, I guess as engineers ourselves in the future, we should also consider the bad stuff, not just the good stuff, because you know, you never know what technology can be done or can do in the wrong hands. So don't build any, you know, time traveling stuff. So keep away from that. So I think I already talked about this before. So there are basically two kinds of context-aware systems, passive and active. So the passive one, basically, the user needs to specifically say what he wants, and the machine responds. And this is what you're normally used to with your phone. You launch an app to get the information you need from the app. But then you also can have the active side. Things like, for example, the Google Maps, the navigation. So if you make a wrong turn, it automatically adjusts so that you can still get to your destination, and you don't have to specifically say to him, like, please find me another, like, new directions because I made a mistake. Okay? And so that's active context systems. So there are several ways of creating context. So you can think about going from low to high level of abstraction. So for example, a GPS coordinate is less informative than, for example, having a street address for you to remember, right? So we can also have this kind of condition. So if I'm here and we are having mobile computing in my calendar, then that means I'm busy. So you can also make this kind of inferences. If all of this is true, then that is false. That is actually easy to do. So if you think about, like, yeah, I'm available to party right now. Not really, but so sometimes it's easier to create context by looking at the rules the other way. So looking at, okay, if these are true, then that is false for sure. So for example, I am here. I'm not in Portugal. You see. So that is easy to make that assumption instead of trying to get, like, you know, what's the address and things like that. So why is it so important? So the thing is that I think I already showed this figure before. So in the old days, people used to use one computer. You used to rent. So in the 1960s, they used to rent a computer that took the space of a whole room, and they would allocate time. In 1980s, people could afford to buy their own computer, have a one-to-one relationship with a computer that you would have at home. This is today. You have multiple devices that you can control. You have your laptop, you have your desktop, you have your smartphone. And what we're thinking about is that in the future, many people might use the same device you have. So owning a device will not be anymore a personal thing, but the device itself will be able to recognize who you are and provide you with information that you have on that device. But someone else can also come over and use the same device to do the same things, but with his information. And that's where we are thinking, like, as scientists and engineers, we think about how can we make a device that is actually able to do this kind of thing. So Google is already doing that a lot with this Google Home platform. So my wife and I and my kids, we can actually control the house by just using voice commands. It knows when it's me talking, and it knows when it's my wife talking. And it only gives you the answers if it actually detects that it's me or her based on the voice. And even my kids. And that's one of the reasons why context is so important, because, you know, you really want to be able to understand what's around. for a system to be able to respond to the user's needs, it needs to know what is his intentions, why is he using this particular system, what kind of information is useful for you right now. And so a lot of that is tricky. It's really difficult. Yeah. So that's it for today. Actually, one of this class will be a little bit shorter than the previous one. Yuki didn't have anything for today.
Yeah.
So I wanted to talk about the project, and if you have questions in terms of hardware that you need or things that you would want to discuss, I'll be here. So the class is over, so it's up to you if you want to stay or if you want to talk a bit about the project. So, I guess not. Did you solve your problem?
No, I tried to take one reasonable application.
Yeah.
Catalog, I can't understand this. What is this even doing? So, this is right. This is right there. This is my space. So downloading something, but I don't know.
So these are the libraries.
You need one, so then I did some libraries, but then update, but I don't know what.
So that's actually key. So that's the build variable keeps track of the application dependencies. And so these are the dependencies retrieving from the repository. So we have support libraries, app impact, so that makes sure that the app actually runs in the
When you get that in the screen, right?
that's what we got.
So what it sound?
Yeah, it's just a sound page.
Okay. Doesn't look like.
Yeah. So this is the. Okay, so this here is the source code. This is where these are just information about what's going on. Filing, we have an error.
So you think
Right now, it's just so once that's done, there's a button.
More detail.
How many gigs have you have?
Yeah, so,
Well, actually, it's
tomorrow.
Now it's just making sure that so once it's done, you see this button that's where it will actually run their you set up an emulator for
whiteboard.
So if you look there,
You can move this.
Okay.
I think it's very good because mathematics is Let's do so that we will put it tomorrow. And so check there and we send yes. So if you have that, plug it in with the USB, and then you also need to be able to and when you do that, then here and lockup, you should send we can do this here. Looks like this compile actually then put the implementation. All of these compile into this stuff.
So the example.
Yes. So
jadi yang tu
I think
Microsoft Windows.
Yeah.
Then there is something maybe
So it's also telling me that the build tools that you have set up on this project is actually also updated. So there's a way to update it. So I'll just do that, and that's it. And that should resolve those. So you have a USB cable, so you can, because I could check whether or not your computer is actually recognizing. I notice you have a Samsung. It might be that you need to install what Samsung calls the USB driver. So then AngularStudio can connect to it. Because it might be just that right now the AngularStudio cannot connect to your device, even though you have the developer mode on.
So I should install those to my phone.
Not to your phone, but on Windows. Because right now it's just Windows does not recognize the Samsung as a development device. That's it. But Kennedy, can you help Vesla here maybe tomorrow to get at least his phone recognized by AngularStudio? Because it seems that he's having that.
You have the phone, yeah.
Yeah, he has the phone, but he doesn't have the USB cable right now. But maybe tomorrow in the lab.
Maybe tomorrow in the lab.
Yeah, he can.
Or in the lab.
Yeah, he can help you get this at least so that you can see that there's something happening. Yes. Yeah.
So you can't let your phone.
It's possible after last time, I have other course.
Oh, you have mobile machine learning?
Yeah.
Yeah, okay. Yeah, that's fine. That's fine. We are on the third floor.
Okay.
Yeah, okay. But you can set up the emulator, because that way AngularStudio will for sure be able to connect it.
Yeah.
So create the emulator image. I canceled it before because it will take a while. So create a virtual device. Choose either one is fine.
So the one, and then the image just use pi. So that's the image. Okay. So just download that. And once it's downloaded, then you can choose it. And press next. Makes it okay with the device. Okay.
By the way, do you know which one was first?
I'm pretty sure it's a scene.
I've been wondering if you know all the history.
I'm pretty sure it's a Symbian.
Yeah, actually, I have a question. It's not run straight to the project, but in Sarah, because I'm studying this kind of possibility that how to run Android from server side. So do you have any
so there's this
experience or?
I've done it a long time ago. So it's a key emu, this emulator engine.
Yeah.
So there's this QEMU.
Yeah, I know. Yeah.
So you can set up that for remote connections.
Yeah.
And then basically it acts as a VNC, like remote desktop protocol.
Yeah.
And you can connect to it and you see the screen.
Yeah.
And that is powered by the server. I've done that like many years ago. But it is possible.
Yeah. But it isn't possible to do it in that way that users times n could use
the same machine.
Yeah.
No.
No,
because I think Android itself does not support that. So it will. Well, I guess you could if you create a new instance for every single device that connects, and then they have their own sandbox.
Yeah.
So then yes, that should be fine.
Okay.
Maybe Docker would be able to do that. So you use Docker containers.
Yeah, no, I'm studying. I never tried. But
okay. Maybe that would probably work. But I can tell you, emulation, depending on the machine, it might be a bit slow.
Yeah.
Yeah.
Okay. But I know that these biggest companies at the moment, they're studying this kind of distributed systems anyway.
Yeah.
So I'm pretty sure that it will go more and more to the cloud server, even the OS level.
Yeah.
So I was just wondering that how would it be possible to do that even with the open source software things?
Yeah.
And
I think it is possible because I've done it before, but I just had one machine. But it was extremely slow, like ridiculously slow, and I gave up on that idea. But I don't know, the emulators themselves nowadays, they actually have improved quite a lot.
Yeah, but
so maybe nowadays it would be quite functional. But I remember before it would take like 20 minutes just to load the machine.
Yeah.
And
but the purpose would be to run this kind of on Android ROM.
Yes.
Of course, not this Google thing.
Yeah.
But basically strip off, for example, this kind of normal phone applications there.
Yes.
Because it's only for web stuff.
Okay.
So in that sense, I think that the ROM itself would be smaller, at least some part.
Yeah.
So hopefully it will be a little bit lighter.
Are you compiling from Android open source project?
Yeah. Right.
Okay. I've done that a lot.
Well, I have not. I haven't studied, or you know that.
So go here. I don't know if you. I don't know if it's .com or .org.
Yeah. Okay.
Go here. They have a lot of tutorials on how to build Android from scratch.
Okay.
And adding packages.
Okay.
You will see some of my work there too.
Okay.
Yeah, I just spent a lot of time there.
Okay.
So I think so when you download the source of this, there's this vendor folder where you can specify what are the packages that you want to be bundled and the image of the operating system. So when you compile it, you reach the package list of what you want. There's also drivers. So by default, I remember the Android operating system, it does not enable 3D. And so that means things like playing a video or stuff like that will be extremely slow. In your case, because you're going to run it on the emulator, it might be that nowadays this is different. But I remember in the old days it was only 2D by default. So it might be that nowadays they actually also have emulated 3D. And this is the image that you can actually run on this EMU. And I guess all you need to do is create a server that loads these one instance per client. And then basically, and then you can regenerate this every time you make a change here. Yeah. Fun project.
Thanks, Nick. Okay.
Yeah, I've compiled Android from scratch for HTC Magic, the Nexus 4, Nexus 5, the OnePlus. I've done it so many times.
I have several Nexuses, so I think that's the best platform for this anyway.
Yes. Yeah.
One question. Because now we are